reagent. The reactants for Grignard reagent are alkyl or aryl, halide, and magnesium. Conditions: it needs the presence of dry ether. So for example, R group attached to X atom. So this R can be alkyl or aryl, attached to the halogen, so alkyl or aryl halide, reacts with magnesium in the presence of dry ether. So this R will attach to Mg. Okay, this R will attach to Mg, and then the Mg will attach to X. Not RXMg, it's RMgX. That is Grignard reagent. The R will attach to Mg, and then the Mg will attach to X atom. Okay, the X can be any halogen, Cl, Br, or I. For example, here CH3, so this is alkyl group, attached to iodine, alkyl halide, reacts with magnesium in the presence of dry ether, so the CH3 will attach to Mg. This Mg will attach to the carbon, and then that Mg will attach to I. So this is what we call Grignard reagent. The uses of Grignard reagents are for formation of alkanes, formation of alcohols, formation of carboxylic acid. Formation of alkanes, the Grignard reagent need to react with water. To form alcohol, Grignard reagent need to react with carbonyl and acidified water, H2O and H+, so H3O plus acidified water. And then Grignard reagents react with carbon dioxide and acidified water to form carboxylic acids. Formation of alkanes. Grignard reagent reacts with water, so in order to form Grignard reagent, you need alkyl halide or aryl halide, reacts with magnesium, so the magnesium will attach to R and it will attach to X, and then it becomes Grignard reagent over here, and it will react with water to form alkene. The bond between Rm and G, this bond consists of 2 electrons. These 2 electrons will be used to attack the hydrogen in water. This hydrogen delta plus, OH delta minus at the O. So these 2 electrons in bonding between RMG will be used to form bond with hydrogen in water. And then that R will form bond with H, and then this MgX delta plus will form salt with OH water. So it's just MgXOH, it's salt. So this is the formation of alkane using Grignard reagent. The bonding of R group form bond with hydrogen in water. That's it. Then alkane can be formed. And the side product is salt, MgX in the bracket OH. So this is how you write the side product, MgX and then in bracket OH. This is the example. For example, you have this 1-bromohexane. 1-bromohexane reacts with Mg in the presence of dry ether. So this is the Grignard reagent. R group attached to Mg, Mg attached to Br. And then this bond, the bond between carbon and magnesium bond, this bond consists of 2 electrons. These 2 electrons will form bond with hydrogen, 1 hydrogen atom in water. And then releasing MgBr, they C release MgBr because they C form bond with hydrogen in water. The product will be alkane and MgBrOH. This MgBr release and then it reacts with OH from water. So MgBr in bracket OH. Next, formation of alcohol. initially show the formation of Grignard reagent from alkyl halide or aryl halide plus Mg in the presence of dry ether to produce Grignard reagent. So in order to form alcohol from Grignard reagent, these Grignard reagents react with aldehyde in the presence of acidified water to produce primary alcohol. So in order to produce primary alcohol, make sure the aldehyde, the carbon that is attached to double bond O, has no R group at all. Both sides hydrogens, no R groups at all. Then the product can be primary alcohol. Means the R group in the primary alcohol is from Grignard reagent. So this R form one single bond with the carbon C double bond O, and then the C double bond O here becomes C single bond OH. So that's how you draw the product of primary alcohol from Grignard reagent. Make sure the aldehyde that you use, C double bond O, has no alkyl group at all. Both sides hydrogen in the presence of acidified water. If you want to form secondary alcohol, so this is secondary alcohol, the Grignard reagent must be react with aldehyde with one R group only in the presence of acidified water. So first reacts with this, followed by acidified water. This C double bond O must have one R group only, because another one R group at the product will come from Grignard reagent over here. So C double bond O will become C single bond OH, and then one C single bond with R group will be formed in the secondary alcohol, and this R group here is this R group. So in order to form secondary alcohol, make sure aldehyde is used, and that aldehyde has one R group only. Next, in order to form tertiary alcohol, you must use here the ketone. This is ketone, C attached to two R groups, followed by acidified water, H3O+, and then the product will be tertiary alcohol. These two R groups from the ketone and one more R group from Grignard reagent. That's how to form alcohol. Depends on the class of alcohol that you want to form. You have to select the correct reagent. Okay, correct reactant. For example, form Grignard reagent first. Haloalkane reacts with Mg in the presence of dry ether and then CH3 MgCl. And if you want to form primary alcohol, you must react it with aldehyde that has no R group at all, both sides hydrogen. So that's formaldehyde. Okay, aldehyde with one carbon only, formaldehyde, in the presence of acidified water, and then it reacts with acidified water, and then ethanol will be formed. Okay, this is primary alcohol. Next, formation of carboxylic acid using Grignard reagent. Initially start with haloalkane reacts with Mg in presence of dry ether to form Grignard reagent over here, and then it reacts with carbon dioxide first, followed by acidified water. The product will be carboxylic acid. So it is R group from Grignard reagent, and then straight away carboxylic acid. That is the formation of carboxylic acid using Grignard reagent. For example, haloalkane reacts with Mg in the presence of dry ether to form Grignard reagent. So this is the haloalkane. This is the R group of haloalkane, and then the R group attached to MgCl. And then it reacts with carbon dioxide first, followed by acidified water. So straight away, that carbon that is attached to MgCl, that carbon's attached to COOH. Okay, not this carbon COOH straight away. this carbon attached to COOH. One carbon comes from this CO2, so it is attached to COOH. So this reaction is useful if you want to add one more carbon. Initially, it has 1, 2, 3, 4 carbon. At the product, the total number of carbons are 5 carbons in total. So if you want to add one more carbon, use Grignard reagent, react with CO2 followed by H3O+.